Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of basic electrical and electronics engineering. We'll dive into key concepts like modes of operation of BJT. Slide 1. Modes of operation of BJT. Introduction. We begin by understanding what a BJT, or bipolar junction transistor, is. It is a three-layer semiconductor device with two types, NPN and PNP. It has three terminals, emitter, base, and collector, and it can be used to amplify signals or act as an electronic switch. The behavior of a BJT is determined by how voltage is applied to the emitter base, EB, and collector base, CB, junctions. These are called biasing conditions. Depending on whether these junctions are forward or reverse biased, the BJT operates in one of the four modes. 1. Active mode, where the BJT works like an amplifier. 2. Cutoff mode, where the BJT is off, acting like an open switch. 3. Saturation mode, where it is fully on, like a closed switch. 4. Reverse active mode, where the transistor works in reverse, rare use. The mode of operation is crucial because it defines how the transistor behaves in a circuit, whether it's amplifying, switching, or protecting. Example: a microphone amplifier uses a transistor in active mode, while a logic circuit uses it in switching, cutoff, or saturation mode. Slide 2. Active mode of BJT. In active mode, the emitter base junction is forward biased, allows current flow, while the collector base junction is reverse biased, blocks current. This is the most important mode when using a BJT as an amplifier. In this condition, a small current flowing into the base controls a much larger current between collector and emitter. This current relationship is defined by the current gain. IC equals beta times IB, where beta is the current gain of the transistor. The base emitter voltage, VBE, is typically around 0.7 volts for silicon transistors. When this voltage is applied, the transistor turns on in active mode and starts amplifying the input signal. This mode is used in audio amplifiers, signal boosters, and analog circuit designs. Significance: active mode is the backbone of analog electronics because it enables signal amplification. Slide 3. Cutoff mode of BJT. In cutoff mode, both the emitter base and collector base junctions are reverse biased. No current can flow through either junction, so base current, IB, equals 0, which results in collector current, IC, approximately equals 0. The transistor acts like an open switch, it is completely off. This mode is commonly used in digital logic circuits, such as timers or microcontrollers, to represent a logic 0. When in cutoff mode, the collector voltage remains high. Power consumption is minimum. Example: when a transistor is used to control a relay, the cutoff mode ensures the relay is off when the base signal is absent. Slide 4. Saturation mode of BJT. In saturation mode, both junctions are forward biased, meaning current can easily flow through both. The transistor is fully on and behaves like a closed switch. Collector current is at its maximum, limited only by the external circuit. Collector emitter voltage, VCE, is very low, usually around 0.2 volts. In this mode, the transistor is used to represent logic 1 in digital circuits. Since the transistor is fully conducting, it allows full current to flow from collector to emitter. It is not used for amplification because the signal gets distorted due to full saturation. Example: in switching applications like LED drivers or digital power control, saturation mode is ideal. Slide 5. Reverse active mode of BJT. This is the least common mode of operation. In reverse active mode, the emitter base junction is reverse biased. The collector base junction is forward biased. Here, current flows in the reverse direction compared to normal operation. However, the current gain is very low, because BJTs are not designed for efficient reverse operation. Beta reverse is very small. This mode is only used in specific protection circuits or reverse current detection applications. Example: some latch-up protection circuits in microcontrollers or fault detection systems may utilize reverse active mode in rare conditions. Though not commonly used, understanding this mode helps students appreciate transistor symmetry in potential behavior in fault conditions. Slide 6. Differences between BJT modes of operation. To simplify the learning of all four BJT modes, let's summarize the key differences. 1. Active mode, used for amplification. 1 junction forward, 1 reverse. 2. Cutoff mode, transistor is off. Both junctions reverse biased. 3. Saturation mode, transistor is fully on. Both junctions forward biased. 4. Reverse active mode, transistor operates in reverse. Rarely used. 5. Current gain, high in active, very low in reverse active. 6. Voltage gain, present only in active mode. 7. Power dissipation, lowest in cutoff, highest in saturation. 8. Application, amplifiers, active, switches, cutoff, saturation. 9. Signal direction, normal in active, reversed in reverse active. This comparison helps students visualize how a BJT acts differently under different electrical conditions.